Hello students, I'm making this video for you all for your doubts on alcohols, phenols, ethers. The first question which you forwarded me was, what is the product obtained when chlorine reacts with ethyl alcohol, that is ethanol? Just for knowledge, ethanol is also called the grain alcohol, the spirit of wine, methyl carbinol, ethyl alcohol, alcohol, ethanol. Anyway, what is the product obtained when chlorine reacts with ethanol? Take a molecule of chlorine, reacts with, just a minute, yeah. So I take a molecule of ethanol, it reacts with chlorine. Chlorine is a good oxidizing agent, so oxidation takes place to give ethanol as an intermediate, which again reacts with chlorine. 3 molecules. Here the byproduct is 2HCl. Here the byproduct will be minus 3HCl, and you'll be getting chloral. So when chlorine reacts with ethanol, we get chloral, also called trichloroacetaldehyde or trichloroethanol. And just to remind you, we have already done this in, I'll tell you the page number in our HDA notes, that is in our notes of halogen derivatives of alkanes on page number H84. Second reaction is this, and the third. This is the second, this is the third reaction. Anyways, just go to that page number and read once again. Next question. Which of the following is the most suitable method for removing traces of ethanol from water? They've given, the other two options are not right, like heating and all cannot be done. One of the option is sodium metal. We cannot use sodium metal because ethanol will react with sodium metal and will become sodium ethoxide. I want to just dry ethanol. I mean, even after drying, it should be ethanol. It should not happen that I add sodium to ethanol to dry it, but then I get some other product, and that is sodium ethoxide. So I cannot use sodium metal. Another option which they have given is magnesium, which is the correct answer. Why? I'll just tell you the reaction. When magnesium reacts with ethanol, first of all, it takes 2 molecules of ethanol because magnesium is divalent. Magnesium is divalent, so it makes use of 2 molecules of ethanol. So here is the reaction. Mg with 2 ethanol molecules gives, of course, magnesium ethoxide, like this. Even sodium will give sodium ethoxide, but further no reaction. Sodium ethoxide पे reaction रुक जाएगा, but यहाँ पे reaction sodium ethoxide तो नहीं है, यहाँ पे reaction magnesium ethoxide पे रुकेगा नहीं. See what's happening. So this you get magnesium ethoxide, which again, first here I am writing minus H2. Now from here we will be getting 2 molecules of ethyl alcohol by treating it with HGO. So MgO अलग हो गया, और वो जो 2 इथेनॉल के मॉलिक्यूल थे जिसमें कि पहले मॉइस्चर था, अभी सूखे सूखे आपको बाहर मिल गए. That's the way. away. I hope it is clear to you. So that is why we are using magnesium to dry ethanol, but we can't use sodium to dry ethyl alcohol. With sodium, reaction will stop at sodium methoxide and we have changed the compound, so what point in drying it? But with magnesium, we do get magnesium methoxide, but the reaction will not stop at magnesium methoxide will further decompose to give me magnesium oxide, and what I wanted, ethyl alcohol in dry condition, is with me. Next question. An organic compound A reacts with Chatri MgI to form an addition product which on hydrolysis forms the compound B. Compound B gives blue color salt. B gives blue salt in VMT. VMT is Victor Mayer's test. Victor Mayer's test. You can check another video along with this on Victor Mayer's test if you don't remember, and you can just revise it and do it. Still, if you have doubt, we again get back to it. Anyway, what we remember was primary alcohol in Victor Mayer's test gives red color. Secondary alcohol with Victor Mayer's reagent gives a blue color, while the tertiary alcohol with Victor Mayer's reagent does not give any coloration. It's colorless. So, we know in Victor Mayer's test, blue color salt is given by secondary alcohol. It means compound B must be a secondary alcohol. B is some secondary alcohol. So this is some secondary alcohol, a 2-degree alcohol, and which will have the general representation RCHR-OH. Now, this is B, a secondary alcohol. Now it says A reacts with Chatri MgI to form an addition product which gives B. Now this is a secondary alcohol is obtained by adding Grignard's reagent to an aldehyde, but not formaldehyde, because formaldehyde with Grignard's reagent gives a primary alcohol. So I have to take any aldehyde other than formaldehyde. So I took any higher aldehyde, treated with Grignard's reagent RMgX, and I get an addition product which is RCO. Here MgX gets added and here R gets added, R dash, and here H. Here we have hydrolysis with acidic water, and here we have dry ether. Okay, so A is an aldehyde and B is a secondary alcohol. You can see the options and select accordingly. Now, an industrial method to prepare methanol. An industrial method to prepare ethanol. Okay, it is in our notes on page. It is in our notes on page 127. APE 127, my handwritten notes, this is there. Anyway, so carbon monoxide combines with hydrogen in presence of ZNO and CrO3. ZNO and CrO3. So, silk oxide and CrO3 at 300 degrees centigrade. In 300 atmospheres, here what we get is methanol, and this is the industrial method to prepare methanol. APE page 127, our notes. Anyway, let's proceed further. The following compound on hydrolysis in acetone, this acetone, gives this the following compound. So that the following compound is this one. Okay. On hydrolysis with acetone, aqueous acetone, what it will give? Okay. So we have to do its hydrolysis in aqueous acetone. Hydrolysis. We have to find what will it give. Okay. So on hydrolysis, obviously the functional group will function. This will break. So what we will get over here, first step is we get something like this, a positive charge here because Cl is broken, minus Cl minus, a CH3 here, a H here, CH3 here, a CH3 here. Now, this is a 3-degree carbocation. This is a 3-degree carbon. Correct? This is a 3-degree carbon. This is a 3-degree carbocation. So, we can get the product. The product can be, I'm just writing here, this can directly give me product via SN1 because 3-degree के लिए SN1 होता है hydrolysis में. I get CH3O and like this. Here one OH will come. Here there is a chhatri, chhatri, chhatri. Okay? And here there is NO2. Here there is a CH3, here there is a CH3, here there is a CH3, here there is a H. This is one of the product. But one more thing can happen. This can get converted to more stable carbocation where this plus will shift here because this is a ERG. ERG is a electron releaser. ये इलेक्ट्रॉन दे रहा है और ये प्लस है, इसको चाहिए तो नजदीक आएगा. So this 3 degree from here can shift here because of the ERG and we will get something like this. Positive will come here. And these are all methyl groups. Huh? I have left these. These are methyl. And obviously this can give me another compound which is like this. OH here. Correct? Here there is 1H less, but all that is understood. ये यहाँ से इधर आएगा, like something I have not written. Don't be confused. It's common sense. Here one more and here one more. So we remove this H. Okay, I just carried it. We just concentrated on this part because that was where the equation was happening. So we get two products. One product directly, which is a minor product, and another product which is because of 1,2 hydride shift, and that is the major product. So this is the major product. Now if in the option they have both, then that is the best answer. If in the option they don't have both A and B or X and Y or K and L, and they have option only this or only this, then this is right. If they have an option where it says this is minor and this is major, that is also right. If in the question they give, so the major product is, so this one only. Okay? Now here. Which of the following gets dehydrated most readily? Now, first of all, identify the functional group. All are alcohols. Identify the functional group. All are alcohols. Now, alcohol during dehydration first becomes a carbocation. Alcohol on dehydration first becomes a carbocation. And children, carbocations are stabilized by, just move a little bit that side. Yeah. So they are stabilized by ERG. O2N is a EWG. Cl is a EWG. इधर कोई group नहीं है, and this is a ERG, methoxy. So this is the answer. Okay, and then finally it will get dehydrated. Question number 7 and the last question in your doubts, that section of doubts. Okay, phenol. We take a molecule of phenol, also called hydroxybenzene, benzenol. It's also known as carbolic acid. With zinc, it gives benzene. Benzene with concentrated H2SO4 and nitric mixture, which is also called nitrating mixture. We get like this nitro. Now the nitro compound with zinc and aqueous NaOH. So nitrobenzene with zinc and aqueous NaOH gives, do you remember? No. So nitro compound with benzene and aqueous NaOH gives, I want somebody to give the answer because somewhere we have done this. It is a reduction, it is a reducing agent. Zinc and aqueous NaOH is basically a reducing agent. So I think you should be knowing this. Okay. So we will be getting we will be getting hydrazobenzene. We have learned this in organic compounds containing nitrogen, that is nitrogen containing compounds. Only thing they took from here, they have gone to, from alcohol, phenol, ether, they connected it to the nitrogen containing compounds. Okay, anyway, I hope the doubts are clear to you. Bye bye, see you, take care, love and blessings to all of you.